Welcome all, hello, and welcome back. Thank you so much for joining us here again on our awesome Out of This World platform, you could say. Saza, good to see you. I hope the hacking's going on. Firstly, though, I'd like to begin by acknowledging the traditional custodians of the land on which we meet and work today. I want to pay respect to the elders past and present and acknowledge the important role all Aboriginal and Torres Strait Islander people continue to play within Australia and our developer community. So welcome to the Digital Defense Hack Cong's Star Trek Security Workshop Edition. We're excited to be here and we hope you are as well. So firstly, if you haven't seen this venue before, you can your mic and camera on or off in the bottom menu. So that's not available while we're in presentation mode as we are now. But when you go back to the tables, if you want to have a chat with fellow participants or just network a little bit, feel free to jump around the tables and do that. You just jump around the tables by double clicking on a chair to move. If you want to ask questions while Cong is delivering the workshop, please feel free to use the Q&A tab. That's in the little chat down the bottom there. If you open that, you should see a Q&A tab and you'll be able to ask questions and vote up other people's questions as well. So who am I and who is Cong and what do we do? So myself and Cong are both part of the IBM Developer Advocate team. We work closely together. And we are, as developer advocates, what we do is not party all night and not burn money like our boss thinks. What we actually do is work closely with clients and the community to help developers learn about and leverage IBM tech to solve business problems and create innovative solutions. So we represent IBM at a lot of industry and events, workshops, meetups, conferences, and we aim to build relationships within that ecosystem and just help you out, really. Like, we just like to have a good geek out session, help you understand the tools so they can help you go about and innovate, really. So we also do a lot of blogs and things like that, try and put together code samples or help you find the resources you need to get going with your hack, basically. So who is our speaker today? I did quickly introduce him, but Cong Nguyen is an all-around legend. He is deeply technical and has a strong passion for embracing emerging tech. And he really does. Every time something new comes out, he is straight on it and knows the ins and outs of it within, a half a day usually. So if you want to ask anything technical about any of the IBM suite, Cong is really your man. He is really an amazing guy, and I've heard the draft of this workshop and I am really looking forward to it. So without further ado, on to the workshop. Cong, I'd like to welcome you to the stage.
Hello. So thank you, Ali, for the introduction. Switch back to PowerPoint. So for this presentation, you will be learning about security containers, and the audience for this particular workshop is aimed towards application developers. And throughout this presentation, you will see a lot of memes, a lot of GIFs, and a lot of animations. Hopefully, Remo is showing through the animation for these videos clearly. So I would assume that you are application developers. You have deployed things to some other platform in the past. You may or may not have used Kubernetes before, and we will go through some Kubernetes concept quickly to get you up to speed of for the remainder of the talk. So in essence, I assume that the following words and phrases have some meaning to you: cloud, cloud native, environment variables, secrets, passwords, private keys, containers, and lastly, IBM Cloud, where you can get a Kubernetes cluster for free for 30 days. Shameless plug. Okay. So for the content, as mentioned, we are going to touch on the why of security for application developers, particularly going to touch on some risk management frameworks and some legal requirements that comes with deploying your applications to your customers. Then we are going to briefly talk about Kubernetes basics, particularly its origin and its relevance to Star Trek. Now, I noticed that Ali showed a stormtrooper or one of those hunters from Star Wars, but we are doing Star Trek today, and that is of critical importance. Then we are going to touch on what is Red Hat Openshift and why we are even going to talk about Openshift when it's a Kubernetes workshop. After that, we are going to go into some Kubernetes architecture, some different attack vectors that can impact the Kubernetes cluster. Briefly talk about container security. And after that, we are going to go into identity and access management, or IAM, or IAM for short, talk about some role-based access control and OpenShift projects, and then move on to network security, where not going to focus on network policies and the internal cluster network security, but more about how network security impacts application developers. So, but in particularly, I'm going to be talking about Kubernetes ingress, OpenShift route, and the service mesh. Then we are going to go into secrets and end with some application hardening. So what kind of tools you can use in your DevOps pipeline to make sure that you are producing a clean and secure image. It's a lot of content to go through. So I'm going to be speaking relatively quickly, and I'm going to try to pronounce all my words very clearly. If you want to still a Jedi. She's not a Jedi. Star Trek stuff. Moving on. So if you have any questions, come into the Q&A section. I will be glancing to my other monitor frequently, so I don't miss any questions. But I will try to get through the rest of the content relatively quickly. And for security can be a dry topic. So to help keep you entertained, there will be plenty of Star Trek related GIFs and memes throughout this presentation. And I'm also going to be including some character names, so you start to learn about the lovable characters of Star Trek. And just a note, I have been through every single Star Trek series and movies. No, a fair amount about Star Trek. So it's going to be fun, is what I'm trying to get at. So after this talk, the presentation will be available on the Help with IBM channel in the DigitalDefenceHack. So throughout the presentation, there will be a lot of links to help you fact check my talk and also to get started with the different topics I'm going to be talking about. All right, so why security and why should you care? So companies typically are required to adhere to industry and national legislations when it comes to information system security. For example, Australian banks like Westpac, Macquarie Bank, or ANZ are responsible for holding and managing your personal information and your money. So for technology choices, for example, they must comply to APRA standards and adhere to their guidelines. So whenever they want to go with a technology, they have to inform APRA for X amount of days before they actually do it and wait for approvals. And for any organization that deal with credit cards, then that organization also have to be compliant with the payment card industry, PCI, Data Security Standard, or DSS. And if you don't work in the, sorry, I'm just watching the down a sec. So if you don't work in the financial industry and if you work in healthcare, then there are also other privacy security laws that you need to kind of know about in that industry, like HIPAA. That is used to define security measures to protect electronic protected health information, and the HITECH Act for your health records. So to meet these legal requirements, most companies have to prepare a risk management framework and submit it to auditors. And typically they have their own internal governance framework that addresses mainly 3 dimensions of security and risk, like confidentiality, which is meant to be protecting the users, all the clients' personal privacy and proprietary information. The second dimension would be integrity, like guarding against improper information access, modification, or destruction that deleting data. And lastly, is about availability to ensure timely and reliable access or use of client information or even companies' information. And to help companies prepare these management frameworks, there are the NIST SP 800-53, risk management framework from the NIST, so National Institution of something, I can't remember the name, but it's always NIST, that deal with security and privacy controls. And as an international standard, there's also the ISO 27301 that deals with information and security management. From the Australian perspective, we have the Information Security Manual That it comes from the Australia Cybersecurity Centre. And also, they also established the Essential 8, which introduces maturity levels and provide a baseline for mitigation strategies. And if you want to learn more about the taxonomy of terms, how risk analysts do their job, then there's also a certification from the Open Group called the Open FAIR certification. And FAIR, I'm pretty sure, stands for Factor Analysis of Information Risk. Pretty long word, a lot of risk here. So as application developers, and for my background, I actually come from, I used to be a mobile developer, then became a front-end developer, back-end integration, and right now I develop advocates in front of you. So as application developers, the reason why I think that we should care is to broaden our horizon, to understand the different risks and complexities when deploying our application to end users. And also, if you are a startup and you want to sell your product to enterprises, then having a risk management framework or policies or governance framework can help accelerate that journey. All right, so let's begin with the Openshift, sorry, not Openshift, the Kubernetes Origin, and why we have so many Star Trek themed references in this particular presentation. Well, so Kubernetes was created by Google. It was heavily inspired by the Borg project. And as you can see on the screen, we have a Borg is like a race of humanoid machines that bench on world assimilation. So they take in organic mechanism, organic, what do you call it? I forgot the word. Anyway, so they try to assimilate and consume all kind of knowledge. The original code name of Kubernetes is actually called Project 7, which is named after a character from Star Trek, Voyager, of name of 7 of 9. And she was a Borg, and she was brought into the Voyager starship and turned into a human being. So to celebrate this reference, the Kubernetes symbol has 7 spokes on the symbol. So 1, 2, 3, 4, 5, 6, 7, 7 of 9. Pretty fun. So let's begin with some core concepts about Kubernetes. So the container, if you come from a world of Docker, is a smaller compute unit. And then containers are created from images. And these images are like layers of that let you run the application in. The container images are stored inside and some sort of image registry. Up to now, we have Docker Hub. There's also Red Hat Key, and IBM Cloud has our own container registry, for example. In Kubernetes land, containers are wrapped in pods, PODs, and a pod can have multiple containers. Each pod has a unique IP address. It's a flat LAN. There's no, pretty sure there's no VLANs available in Kubernetes. To identify pods and containers and to manage different pods, Kubernetes use labels as simple key value to identify a pod. So for example, in this particular example, we have a pod with a row of backend, and that's a label. Label is row backend. Kubernetes introduced a concept of services. A service is like a load balancer for your pods. And for different, if an external pod, like a front end pod, want to talk to the backend pod, they would go through the services to access the different backend services. Yeah, so when a new pod with a role backend is spun up, it will automatically join these backend service because this is what you have defined for it to do. Now, there are in Kubernetes land, in OpenShift land, we're going to talk about OpenShift in a sec, but I'm just going to mention a concept here called the OpenShift route. A route essentially exposes a DNS name for your service. And it uses the cloud provider load balancer to do this automatically for you, which you don't need to know about it. We had a scene route implemented by an HA proxy. And there are some benefits that goes with that. And the last concept for this that is relevant to this talk is the persistent volume and claims. So pods essentially are ephemeral, and when they go away, all information is lost. And the way that you go around it is that if you want your data to be stateful, then you need to reserve a volume or some persistent storage for your workload. So you create a persistent volume claim, for example, 2 gigabytes. And if Kubernetes say, yep, we have space for you, it will give you a persistent volume of 2 gigabytes that can be accessed by your workload or applications. Right, so we've mentioned OpenShift. So what is it? So you can think of OpenShift as Kubernetes, but with a lot of tools and toys included in it. So for example, if you are running just Kubernetes by itself or you want to play with service meshes like Istio, with Kiali to visualize the service mesh, and with some Jaeger to trace all the network calls, well, you have to install that yourself. But Red Hat OpenShift create a bundle called OpenShift Service Mesh, like just bundle all of it and just give it to you as a consumable. They also have the OpenShift serverless, which are packages Knative and include the OpenShift Service Mesh as a part of it. And OpenShift is really geared towards developers. So they also created a tool called Odo, which happens to be the name of the chief of security from Star Trek Deep Space Nine. That works like a GitHub push. Sorry, it works like a Git push. You say Odo push, and which will push your application through a build pipeline internally and create a container image for you automatically. So you don't have to write any Docker file for it. If you've used things like Cloud Foundry in the past, it's kind of similar to it. Also, Tekton. Red Hat didn't create Tekton per se, but they are a core part of the teams that try to integrate Tekton and Jenkins and build it into your Kubernetes-based cluster. So the thing about all this good stuff is that you have to pay a bit of extra money for it. And if you kind of don't want to install Kubernetes or OpenShift by yourself, there are, I think, only 2 completely managed providers. So there is Red Hat themselves. They manage their own, they manage the OpenShift cluster for you. And there's also a managed OpenShift service on IBM Cloud that has hourly billings. And from a security perspective, if your core business isn't to run a Kubernetes service for other part of your organization, then sometimes it pays to use a all-in-one service like OpenShift. And as a case study, for example, we have when I say we, it's mostly because IBM bought Red Hat in 2019. So anyway, so the Macquarie Bank started using OpenShift 3. There's also OpenShift 4 nowadays, but they started using OpenShift 3 in, I think, 2017. And they go on and talk about it at an OpenShift conference. And this was announced a couple of months ago, October. So it was announced last month that ANZ, the bank, is moving all their traffic for internet banking to OpenShift platform by March 2021. So there are some big banks around this, and they have so many regulations to follow. So it's a pretty good example of big clients using OpenShift. All right, so enough introduction about Kubernetes and OpenShift. Let's dive into the security portion of Kubernetes. So first, let's walk through some high-level Kubernetes architecture to understand the different attack vectors and the risks involved. So to run a Kubernetes cluster, which is denoted by the light gray box here, there are 2 portions of a Kubernetes cluster. You have the master node and the worker node. The master node hosts the Kubernetes control plane, which includes the API server, the scheduler, and the controller. The etcd database is a separate component to the Kubernetes control plane. So what does it all mean? So the API server, if you've used Kubernetes in the past, is that you say something like kubectl get pods, and that command is going to send a RESTful request to the API server that's going to query the rest of the Kubernetes control plane for information and return the result to you. And when you say something like please deploy this particular deployment for me, the API server is going to talk to the scheduler and ask it to have a look at all the available space and see which kind of node where it can deploy the actual workload. And the controller itself is responsible to make sure that the deployment is actually deployed and it's running the number of pods, or making sure ensuring the workload is running correctly. The etcd database is a key value store that hosts all of your configuration settings and also your secrets, which we are going to touch on later. So the etcd database is separate to the control plane, and this allows other vendors like Rancher, K3s, Kubernetes distribution for embedded devices use a different implementation like SQLite for their Kubernetes distribution. Typically, the etcd database is hosted on a different node. If you are running if you're using a Kubernetes cluster by a cloud provider, but to save space, you can also run etcd inside the same master node at the control plane. Then, so the control plane is only responsible for like managing the cluster. They don't actually run the workload. For running the workload, you need to rely on the worker nodes, which the kubelet is a binary or a process that listens that commands from the control plane and actually execute and provision the workloads. And when it's got like command say, please deploy a workload by the control plane, it then actually deploy the containers and application inside Kubernetes pods inside the different worker nodes. All right, so how can you attack a Kubernetes cluster? Well, on the right-hand side of this slide, I have a table of some attack vector and the risk involved and how you would mitigate these risks. So if you or if some hackers have access to your node, then your entire cluster is basically compromised. And that means that you can just delete your cluster, for example, or go into and have a look at individual installation files that make up the cluster, have a look at some secrets that are stored on the node itself, for example. And the way you protect your node against this particular attack is by putting authentication and authorization and encrypt the SSH connection to your node. If the hackers have access to the etcd database, then they can read the secrets, the labels, and the different resources that are running the system and understand how to hack into your other components. And some mitigation strategies on this is to run the etcd database inside its own virtual private network or different node and use some secure communication between the control plane and the etcd database. If they have access to your Kubernetes API server, then that would also compromise your workload, your servers, because they can, for example, deploy or delete things. And for that, use encryption, certificates, and authentication. And if they can inject traffic into the control plane, then they can replace authentic Kubernetes modules with their own forks. So Kubernetes is open source, and people can develop like forks for there are different versions for that for those components in the control plane. The mitigation strategies are to use encryption, to rotate credentials, apply patches regularly. And if they have access to your kubelet, then they can run malicious workload or apply some malicious action to your workload, like just delete a pod outright, for example. So the kubelet should be only able to communicate with the control plane, so these components should not be exposed to the outside networking. And then there's a container runtime attack vector. So we are going to touch on the container runtime in the next section. We'll talk about container security. So if the container runtime is compromised, then the workload can also be compromised. And if you're running your containers as root, then they can escalate some privilege to the host node and do some and compromise the host that way, which is compromise the entire cluster. So as application developers, you don't really need to worry about anything up above the container runtime, and including container runtime, because these are typically taken care of by your cloud provider or your Kubernetes distribution or platform like Openshift. And so as application developers, what you need to worry about, however, is to make sure that the privileges so the code cannot escape from the container to the host. And what this means is that if a hacker have access to your container, like they can use bash shells into the actual container, they can't impact the rest of the underlying file system on that particular node. So some mitigation strategy is just to not use root as inside your use root as a user in the Docker file itself, and also to prevent escalation. And this particular rule is actually the responsibility of the admin. We're gonna touch on this on the role-based access control a bit later. And also, as an application developer, you are responsible to make sure that the traffic is locked down, so you do not compromise your users' data or have the container access the host if the root is used. And this is just all about practicing good application security hygiene. All right, so we're gonna talk about next about how containers work inside Kubernetes. So Kubernetes up to now has been a Linux-based container orchestration platform. Kubernetes is enabling Windows container to run at the moment, but that is not quite a stable technology yet. So we are just going to be touching on Linux, containers in Linux for now. So from an operating system perspective, a container is a process that runs in isolation to other processes. A Linux host creates this by creating a sandbox using a kernel feature, such as namespaces and control group. So on this particular slide, as you move from left to right, we have basically three different ways of running your application, but there are always three basically layers of abstraction that happens. So you have your operating system kernel layer, your user layer, and your actual application related runtimes and dependencies. And in the container land, what it does is that the container share the same OS kernel as the host. So that means that if you go back to the previous slide, if your container runtime is compromised, or if it has some privileges that it can impact the host kernel, then that means that you start to actually impact the host that is running your containers itself, if that makes sense. Cheers, Asa. So what that means is that we are going to go through why that matters in a sec. So when it comes right after, the best practice here is that only use what you need and do not escalate, or don't use root. And this is going to be re-emphasized as we go through the rest of this presentation. Because there are different Kubernetes distribution, I think it's going to be essential to talk about the different container engines available. So in Kubernetes land, there is this thing called the Container Runtime Interface, or CRI. And what it do is that it implements a interface that your Kubernetes is going to use to say, please provision these workloads for me. In Openshift, we have this thing called CRI, which is a container engine, and it implements the Container Runtime Interface. And it stands for Container Runtime Interface for Openshift. And to actually provision the work, however, there is another container runtime. Sorry, CRI is a container engine, and there is a container runtime separate that actually implements the features that the container runtime interface promises to implement. And for Openshift, this is called runC. Also for Docker as well, this is called runC, which is a container runtime that actually create the containers. Openshift, for example, use CRI as the container runtime. Another Rancher uses, I think, Docker as their container engine. Okay, I'm getting the runtime in engine mixed up, but at a high level, Docker and Openshift Docker and CRI uses runC as their container runtime, Why should you care as application developers? You don't really have to be perfectly honest. And so to manage different privileges and access controls to the containers, there is this concept called container context. Called security context. So the security context does a lot of things, as the slide lists here. But as an application developer, you typically do not have access to any of these because they are managed by the cluster admin. So some guidelines: just don't use root as the user who is going to be running your container workload. And do use this thing called the Red Hat Universal Base Image, which we are going to touch on later in the application hardening section. Okay, so the next part is to talk about identity and access management. So similar to Kubernetes security, IAM, which I'm going to say IAM from now because identity and access management is kind of, well, a long phrase to say. IAM also deal with privileges in a sense. So RBAC, or role-based access control, is the industry standard way of managing, well, permissions of users in Kubernetes and Openshift. In RBAC, so going from the bottom of the diagram on the right, we're first going to talk about users. We're just going to talk about users. Groups are basically a logical boundary that manage different users. There are about 4 different types of users in Kubernetes. There might be more, but there's 4 that you need to know about. First one is called regular users. These are real people, and these can include the cluster admin and yourself as developers. Then we have, and the concept of a user doesn't mean that it has to be actual people. It can be system users as well. So the second one is called a system user. System users are infrastructure services, components that talk to the Kubernetes API. So when you first spin up your Kubernetes cluster, your OpenShift cluster, and at this point, you might know that I'm using the word Kubernetes or OpenShift interchangeably. They are basically the same thing in my line of work. So a kube admin is the very first user that is created with Kubernetes, and it has super privileges that basically it can do everything. So when you first created a Kubernetes cluster, if you ever had to do so, the first thing is to create some cluster admins and lock down the password for kube admin or just delete it. So no one else can use the kube admin except for you after that point or before that point. Then the next kind of user is the service account. So service accounts are user objects that are intended to run non-interactive workloads inside Kubernetes. For example, is a pipeline account that is used to install a CI/CD toolchain into your Kubernetes cluster. And this particular service account is going to be used to, excuse me. I had some Red Bull beforehand. It's just coming up. So a service account is used to, for the example I'm referring to earlier, that the service account that was used to install the pipeline. It can also be used to run the actual pipeline work, so do the continuous integration and continuous delivery related tasks. So build, deploy, packaging, the kind of thing. And that way you have some traceability across the line that this particular user did this at that time. The last kind of user is called a virtual system users. These are actually hard-coded users, and they typically begin with a system prefix, like system anonymous, for example. The system anonymous is used to track failed authentications or users try to access resources they're not supposed to do, they don't have access to. The diagram on the bottom left of this kind of explains how that works. So in order to sign into a Kubernetes cluster, Kubernetes out of the box comes with some authentication methods, like using password file, which are HT password file that you might be familiar with if you come from Apache or PHP background. They use X509 certification verification internally to manage the communication between the control plane components for Kubernetes, and they also have token files. But in a vanilla and fresh Kubernetes installation, it requires external integration for other protocols like LDAP or Kubernetes or SAML or OAuth2. This doesn't mean anything to you, don't worry, because, well, I mean, if you do work with application security, you do kind of have to know about these. But if you don't, it's okay. These things should be set up by your cluster administrators. And Red Hat OpenShift, it comes with a pre-integrated OAuth2 server to help you integrate with these with other identity providers and to manage the authentication. Well, the next part, moving up the stack on the right-hand side, are role, actions, and role bindings. So when you want to give user access to certain resources in Kubernetes, and when I say resources, I mean things like a pod, a deployment config, a config map, or secrets. You need to define the list actions or verbs that to actually use these Kubernetes resources, and some verb will be like get, edit, or list. So if you work in a command like say kubectl get pods, get is an action, for example. So there can be two types of roles. There are cluster-wide roles that affect the entire cluster, and there are namespace-wide roles that only exist within a namespace. And as we talked about earlier, a namespace is a way that you can run a project or workload in isolation to other workloads. So Kubernetes also comes with some default roles. Some of them that we have talked about in the past are cluster admins. These are user-facing roles, and these are reserved for the people who will be managing your entire cluster, installing operators, that kind of things. And for individual namespaces, you also have admin as a namespace-wide role. Aside from cluster admin, if you want to give your users like just some permissions like editing and viewing different resources, there's also cluster view, cluster edit, admin view, edit, and so on and so forth. For the control plane components, there are default roles such as excuse me, such as system kube controller manager or system node. And so to assign a user to a role, you would use this thing called role bindings. So that means that you can assign a user to multiple roles with role bindings and vice versa. Right. Oops, sorry, double click there. Let me go back once. So in Kubernetes, so in OpenShift land, we have this thing called projects. And projects are just like namespaces in Kubernetes, but it uses role-based access control to limit a user to only have access and privileges to certain projects. So for example, this particular user have access to the payment namespace or payment project in the development land, but do not have access to the production, to the inventory, or to the catalog projects. And so this is like OpenShift exercising the principle of least privileges, which means that people or automated tools can only access only the resource they need to do the jobs. Right, so on to networking security. So networking is a major threat vector. So well-known network attacks are denial of service, distributed denial of service or DDoS for short, man-in-the-middle attack, and also automatic continuous port scanning for breaking attempts. So talking about networking can send us down to the operator or managing of the Kubernetes cluster really quickly. So instead, we are just going to talk about ingress, route, and service mesh. All right, so a quick recap on what routes are. Route makes services accessible to clients outside the environment with a real URL. And the way that I achieve it is by using the load balancer that comes with the cloud provider. At a fundamental level, what are the differences between a Kubernetes ingress and OpenShift route? This is the list. From a security standpoint, OpenShift routes let you do more things. For example, in this particular chart, we see that ingress and route support edge termination, and we are going to go over what these mean in a second. But route supports a few more security features, and we have re-encryption and pass-through. And you can do things like splitting traffic to different workloads, for example, without having to use a service mesh. Oh, and also one more thing is that not listed in that slide is Openshift route can work with HTTP2 and non-HTTP protocols as well. If you use things like pass-through, for example, which we're going to talk about in the next slide. Right. So I'm just going to go over what does edge, pass-through, and re-encrypt means. And if, as you earlier, just remind myself, edge termination is supported in both the Kubernetes ingress and OpenShift route. Right. So there are 4 TLS termination methods in OpenShift route. The first one is called none. Basically, just means that you are not encrypting your traffic. Anyone can go through. And we should not be doing that unless it's just like a non-production workload, for example. For edge termination, it means that from the client browser or applications to the router or to the ingress, that particular connection is encrypted. But once they reach that point, the traffic inside your cluster is not encrypted. So if you have things like, if you're using the cluster with some other people that you don't know about, you don't trust, then those people can spin up like parts of services that sniffs your workload, and that can be bad. And for OpenShift on IBM Cloud, well, they use the certificates that come with OpenShift cluster that is given to the cluster by IBM Cloud. So it's a trusted certificate. So your client is going to see a green lock on the browser as an example. Then you have the re-encrypt termination. And what this means is that when the traffic comes into the cluster, it's re-encrypted again before arriving at the application. And you might wonder, why would you ever do this? It sounds like more work for the application, because if you are encrypting, actually, if you are doing some TLS termination, that means that you need to provide a trusted certificate by a certificate authority. So this particular pattern is actually used inside Istio service mesh, for example, where every communication, all the communication inside the service mesh is encrypted with mutual TLS, which we are going to touch on in just a second. And the last one is called the pass-through termination, all the way through from client to application. Well, it's using the same encrypted connection. And what this means is that you can use things like HTTP2 and non-HTTP TLS endpoints. For example, if you want to expose a database or expose a message queue connection, you can just use this one and just go through. So Red Hat provides a video on the link here that you can have a look at a bit later after this session that goes the video of how you can use these different terminations to implement an end-to-end encryption demo. Right. So why would you want to use service mesh? Well, as we talked about earlier, if your application happens to use edge encryptions, once that traffic arrives at the cluster, that traffic is not going to be encrypted inside the cluster. And you want to encrypt that traffic. So if you have like noisy neighbor or other neighbors that you do not trust from other teams, it would help with this particular side of in-cluster security. So this particular diagram of Istio might look a bit different to all the other service mesh diagram that you've seen before. And the reason for this is, I think in Istio 1.5 or 1.6, they re-architected Istio to merge all the different Istio control plane components into one monolithic application to simplify deployments and make sure that everything is like smaller to deploy. They are also replacing the mixer, which deal with I think telemetry and encryption and authentication with WebAssembly, which is quite exciting for me as a application developer. All right, so in a service mesh, what it does is that protect the traffic between. So Istio have mainly three main security benefits. The first one is that it protects you against man-in-the-middle attacks by encrypt all the traffics from ingress to egress. It's a mutual TLS, and it gives you fine-grained control policies to provide access control to each individual services, and excuse me. And it's also auditing tools that determine who that can give you some traceability into who did what and when. So what it and how the service mesh does this is that it injects an envoy proxy. Excuse me. We are so editing all of that out. So if you ever see one of these icons, that means that this is an envoy proxy, for example, an envoy proxy. So Istio can only support certain traffic before coming in and coming out of the service mesh, and these would be some TLS encrypted traffic using JSON Web Tokens. Inside the service mesh, they are encrypted with MTLS, mutual TLS, and they support HTTP, gRPC, and TCP networking. As this is a kind of new architecture, there's also two separate versions of OpenShift Service Mesh. There's Service Mesh No Editing Live. Oh my. Okay, so there is a Service Mesh 1.0 or 1.x that have the older architecture where they separate out the policies, they separate out the Citadel, which manages the certificates, and the pilot, which controls like the different envoy proxies, sidecar ports. And there's the Service Mesh 2.0 in OpenShift land that implements this new architecture. So the main difference between OpenShift Service Mesh and Istio is that Service Mesh implements a zero trust network, so not all of your applications can enter the service mesh. They need to be assigned by a cluster admin to enter the service mesh. And also, I'm not sure whether this is actually possible in the community Istio or not, is that in OpenShift Service Mesh, you can have multiple control planes for each of your teams. You have an accounting control plane that may not be using Kiali for visualizing the network, and you can have a human resources control plane for that team. Oh, I just realized that we are nearly up until the hour, but we're only about halfway through. So I will try to speed this up a lot more. Let's move on to secrets. This section will be short and sweet. So when it comes to secret management, I assume that you are using a cloud provider to manage your Kubernetes cluster for you, because they are going to be responsible for encrypting all of your secret at rest. So they encrypt the disk, and as an application developer, you will not be able to see other teams' secrets. So there are three main ways to pass a secret to your workload. You can build a secret into the images. Totally not recommended. You can use environment variables, but people who have access to that particular part can kind of see the environment variables, so that is not recommended. The last way is to map the volume inside a container to contain the file to the secret, and you can just pick it up inside our application and use it. So secrets inside Kubernetes are stored in the etcd data store. By default, they encode the secrets as base 64. So if a cluster admin goes in and decode that base 64 secret, they can actually see your password, they can see your private keys. So some other ways that you can protect yourself is by encrypting that database, or to move the actual keys outside of the cluster entirely to a secure store. like IBM Key Protect or HashiCorp Vault, or maybe your cloud provider key management service. And the last part is going to be, we're going to touch about how you can harden the applications. And this is typically going to be with a DevOps pipeline, or the buzzword nowadays, a DevSecOps pipeline. All right, so to start with securing a workload, you need to start to think about what kind of base image you need to use. So when developers start developing applications or to start experimenting with container images, they typically pull a random image they obtain from, not saying Docker Hub, but for example, Docker Hub because it's the most popular, and use that inside the applications. And why Docker Hub, I think, has some security postures around these images. They can also pull some random like base image and use that in their application as well. And this can, have things like using root as the user inside that particular base image, or has some privileges that can compromise your workload. So a way to go around it is to use these things called Red Hat Universal Base Image. These are images that kind of follows the best practices for security from Red Hat Enterprise Linux. They based on RHEL, and when I say RHEL, I mean Red Hat Enterprise Linux, and they follow RHEL release life cycle. So Red Hat has built some language-specific images for Python, Node, Ruby, PHP, .NET Core, .NET 5.0, and for the proxy Nginx. And you can find some some universal-based images on Red Hat ecosystem catalog as a link here. And when I searched for this yesterday, I can see that they have built an image for Node.js 14, for example. So they keep up to date with the different languages. And the second concept about application hardening is to use golden images. And what golden images are like, so you start off with a trusted base image from Red Hat, for example, and to build these images up for your company's workload. So maybe, for example, you might want to include very specific middleware, or perhaps some very specific like OS user layer libraries that you need to use for your whatever workload you have. Well, what good images are is that you use a trusted image and then apply security scanning and vulnerability and compliance scanning on top of it to make sure that it actually meets some auditing rules that you have defined. So in this particular example, which I pulled this diagram from the Openshift security guidelines, they are using this thing called the OpenSCAP, which is a security auditing tool, which is used for to manage the compliance and vulnerabilities for the Red Hat Enterprise Linux operating system. You might have other auditing tools to use within your organizations. And at the end of this particular pipeline, what they produce is a golden image, an image that is suitable for your applications. And once you obtain the image, you will then use this as a base image for your applications, which is a different pipeline. So within IBM, we have a container software certification program that is used to certify our own middleware. So like IBM MQ, or what's the other one, Cloud for Data, to do all your data processing and machine learning stuff. All of that had to go through this had to go through this software certification program to make sure that they meet standards and they carry some best practices when it comes to security. There's also an open source asset called the Calamity Toolkit that you can use that offers like an end-to-end software development lifecycle with some tools you can use to harden your application images. And I'm gonna show you some components that are included in that toolkit. So it integrates together all the tools that you might use from the CNCF Foundation, Cloud Native Computing Foundation. It provides Git-based templates that includes Helm chart, Helm chart templates, and also define some, I think, scripts that help you move that particular base GitHub base repository through the pipeline. It will make sense if you come back to the Clarity Toolkit link and use it. But then, so once you have created a base, once you have selected a base template and push that through the pipeline, it's going to use SonarQube to do some static code scanning, which identifies things like whether your code have smellies or not. Do some code review on that particular source code. SonarQube can also be used, I'm pretty sure, to detect whether you have stored passwords inside your source code. And if you use integration, and the way that they use integration kind of loosely here, in my opinion, is that if you use contracts for your APIs, then you can also test that against the packed API contract testing tool. And so, and I see that the event will close in 2 minutes, so maybe Ali can do some magic there. So after that, you can then package and build, and the toolkit will then package and build your application image. And sorry, the toolkit will then use that source code and build the image and then store that into IBM Cloud Container Registry and store the artifact of the Helm chart into JFrog Artifactory. That we then deploy to different environments like dev, test, and start using Argo CD, and enable some and use Jaeger and Login and Assistic to like monitor the workload in these different environments. And you can specify whether you want to use Tekton or Jenkins to do the work. So it's like a all-in-one tool that helps you get started with hardening your applications. And that comes to the end of our talk. Thank you for listening. I know it's been a long while. All right, any questions, Ali?
Oh, I gotta, quote 2020, gotta unmute myself there before I start talking. Massive thank you, Cong. That was awesome. We are hanging around in the Slack channel, help with IBM if anyone wants that. And ask Cong any more details on that. Thank you for joining us. I'm sure you learned something new. I certainly did, even starting with the Borg reference for Kubernetes. Thank you for that, Cong. Appreciate it. There's a couple of other conferences coming up as well that I wouldn't mind getting across while we're all here. There's a Data and AI conference where if you have done not a lot with Data and AI, you can get started. You'll get accredited at the end of the course. And it goes through all the kind of skills you need to start out in data and AI and data science, really. So check that out if you're interested in that. It's on November 24th for India and Asia Pacific, so this Tuesday. We've also got an Oz IoT. If IoT is your thing, we've got a couple of great speakers coming from that. So Rajiv and Josh Morley, who I'm super looking forward to hearing from, are going to chat to us at Oz IoT on Wednesday night. And we've got an IBM developer meetup coming up as well. That's in December. We'll be talking to our Call for Code hackathon winners. So this is a global competition that we run each year. It's on again next year, so it might be something you're interested in joining since you're all obviously lovers of hackathons. So Call for Code is a tech for good hackathon. It runs all year. It has a $200,000 prize associated with it. So hit us up if you want to know any more details about that, or come and check it out at the December IBM developer meetup. Again, thank you so much, guys. The recording for this will be up shortly as well, and we'll talk to you soon.
Well, Ali, I just saw some questions in the Q&A section. Should we address it now or later after the...
Oh, yeah. Let's address them now. Sorry, I totally missed them as well. My bad. What a terrible co-host. Thanks, Coggy. Let's do that. So how big is it? Risk? How big is our risk? Is it how big a risk is it that some companies don't have proper security hygiene and deploy insecure containers apps to fully manage Kubernetes clusters of a risk. Sorry, should have read that line too. Thanks, Saza.
I think would depend on it would depend on your security posture and what kind of compliance your company has to do with. I think that's a main one. But if you deploy some really poor, I suppose, workloads with poor security onto your environment, but then you apply some sort of API gateway in front of it to limit access into that cluster itself, that might alleviate the poor hygiene that this particular company, that these particular companies practices. Hope that helps. So it really depends is what I'm trying to get at.
I'm sure Saza will hit you up if he wants to chat more about that as well. Thanks for the question. And Riaz asked, what are security features to consider for mobile application deployment in the OpenShift?
I don't think you can deploy mobile applications in OpenShift. It's really geared towards, like cloud native web applications deployment. Like if you mean things like a mobile backend, then we follow basically the same security guidelines and standards here. Hope that helps.
You can use Node, Java, any kind of language to deploy to a secure Kubernetes cluster, right?
Yes.
So it'll be a similar workflow there on that one. Thank you for the questions, guys. Oh, we've got another one too. Yep, mobile background.
All right, let's chat on that a bit after because I need to clarify what that means.
Yep, so Cong will probably jump over to your table if you want to hang around for a little while, Riaz, and have a chat to you about that one. Again, thank you so much for joining us, guys. We hope you learned something, and massive thank you to our ever knowledgeable and talented Cong for that presentation on Star Trek, was it? Not Star Wars? Kidding. On Star Trek. Thank you very much, Cong. Appreciate it.